What we're going to do here is come up with the expression for the average value of a function. It involves an integral. We're going to do this differently than they did in the book. I think they're both valid. I think if you do this way, you should absolutely read the book. If you read the book, you should absolutely watch this way. Meanwhile, the idea is we start with any old function we want. It can do all sorts of wiggling. It's going to start at A, and we're going to end at B. I'm going to call this f of t for the moment. It can be any function at all, but in order for us to use the fundamental theorem of calculus, we need to think of that as being the velocity, and I certainly can think of that as something speeding up and slowing down, that sort of thing. So for the moment, I'm just going to say, look, it's going to be the velocity of some function. That allows me to actually start calculating average velocity, the way we normally calculate average velocity. Average velocity is always change in position, like that, over change in time. Now, the change in the position is just going to be s of b minus s of a. Change in time is just going to be b minus a, like that. Now we're going to use the fundamental theorem of calculus. We don't usually go this way, we usually go backwards, but s of b minus s of a, we know how this works. It's an integral from a to b of s prime of t dt over b minus a. Can we see that? Almost, yes, like that. We're almost there. Remember, we started out with the function f of t. I interpreted it as a velocity so I could come up with something. But now I'm going to plug back in and say, look, s prime was just our original function. And so what we're going to get is just the integral of the function divided by b minus a. So this is actually going to be the definition of the average value. If you watch the way they do it in the book, they come up with this in a much different way. If we had more time, I would rather do it that way, but we actually come up with the answer this way. And we can interpret this in terms of the original graph, which is really kind of cool. It's so common, by the way, that if you go to graduate school in any field and you take the graduate record exam, you're going to see a question like this on the analytical part. So it absolutely shows up. Now, what am I going to do? I'm going to say, look, this is an average value. I know it's not the very top. I know it's not the very bottom. It's some number in the middle. I'm just going to call that average value A. And what I'm going to do is multiply both sides by b minus little a. So I'm going to get that the average value times b minus a is equal to the area under the graph. I want f of t here. F of t, f of t, f of t. So I have f of t like that. Now, why is that important? Remember, when we multiply two things in a math class, that's always supposed to be the area of a rectangle. So what we have is we have the area of some rectangle equaling the area under the graph. Now, what I want to do is look at a couple possibilities. Could A be here? No. If A was there, the area of this rectangle is way too small. Could A be the very top? No, because this area of this rectangle is way too big. What we want is a height somewhere in the middle. And I think I'm going to try to use green. So that the area of the rectangle is exactly equal to the area under the graph. And it's got to cut something like this, I think. Let's just see if we like this. Nope, I don't think that's high enough. And we'll discuss why in just a second. I'm thinking maybe even up here. So I'm going to try to get rid of these little green smudgelets. Like there and there. And what we want is the area inside this rectangle being exactly equal to the area under the graph. Well, how are you supposed to figure that out? Well, this is really cool. The idea is, suppose the original blue line was a landscape and you wanted to build a road. And you want to build a road at exactly the correct height so that the dirt above the road would exactly fill in the holes below the road. And you can see if the area of the green rectangle is equal to the area under the blue graph, right? You could actually just cut out this little piece and paste it in here, cut out this little piece here and paste it in here, and that way you know you have found the average value. It's not just that the area of that rectangle is equal to the area in the graph. It's that you're building that road at such a height that all the extra dirt that normally you'd have to carry away exactly fills in the holes that would actually pave your road. So that's actually the right way to understand average value, at least geometrically.